Section 5.4 is about factoring polynomials. You learned how to factor back in algebra, and here you have a summary of all the different methods of factoring that we used. You can always try to do a GCF. If there are two terms, you can use what's called the difference of squares. We learned that in algebra. Now these two right here, the sum of two cubes and the difference of two cubes, we didn't do that in algebra, so when we get to one of those, I'm going to have to show you the pattern. If you have three terms, you can use what I've called the diamond in the past, or you can use this perfect square trinomial idea. And if there are four more terms, we use a method called grouping. We're going to look at each one of these and just review how to do them. Here we have an example, and no matter how many terms I have, we always want to look to take out a GCF, and it looks like there is one in this polynomial. Each term looks like it has a 2 in it, and they all have a single x in common and a single y. So I'm going to factor out a 2xy, leaving behind a 3xy. Here I factor the 2 and the x out, so the y squared is left. And here factoring out a 2, left with a 3x squared, and I took the y out. So there we go. In this example, we see four terms. There is no GCF that I can take out. And when you have four terms, the method we're going to use is grouping. So here's how you group. You take the first two, group them together. The last two, make sure you include the sign in front of that third term. Now we take out a GCF of a squared. And if I pull the a square out, I'm left with factors a minus 4. And then I can pull a GCF of a 3 out of the second group, again leaving me an a minus 4. When you group, your goal is to make these two groups match. And now that they do, I can take a minus 4 out as a new GCF, leaving behind an a squared plus 3. And that's what goes in the second binomial. Now if this continued to factor, we would do it, but I can't think of any other way that factors, so I'm done. Here we have a trinomial. There is no GCF. So I'm going to use the diamond method. I multiply the first number and the last number, and that goes on the top of the diamond, so 30. And then on the bottom we put the negative 13. I need two factors of 30 that add to be negative 13. Now if you can't think about it right off the top of your head, you can at least list all the factors. 3 and 10, and then 5 and 6. And now look at those factors and think, how can we arrange these numbers with the signs to get a negative 13? Well, it looks like a negative 3 and a negative 10. So those are my two factors that I'm going to use. Now, because the leading coefficient is not a 1, I'm going to use 5x in both of my binomials. And then the factors in back I'm going to use are minus 3 and minus 10. Now the last step is to do deflating, or to deflate. The way you deflate is you take out a common factor and throw it away. 5x minus 3 doesn't have any common factor, so that doesn't deflate. But 5x minus 10 does. I can take the 5 out, and then again throw the 5 away, and this is what my trinomial factors to become. Here's two terms we're asked to factor. I do have a GCF. I can take a 3 and an x out, leaving a y squared minus 16. Now look at what's in the parentheses. This is called a difference of squares. Here's the difference of squares pattern you can look at. In this case, if I'm going to factor y squared minus 16, I make it a y and a y, 1 plus and 1 minus, and what squared gives me 16? 4 and 4. Here there's no GCF, and the way to factor this is to recognize these as a sum of cubes. Here we have the patterns for a sum of cubes and a difference of cubes. This is a sum of cubes, so we want to think about it this way. CD cubed will come from a CD cubed. And what cube will give me a 27? The answer is 3. Now I write this down so that we know what is being cubed in each one of these, because the first thing that's being cubed is my A, the second thing that's being cubed is my B, and now I can use this pattern. So according to the pattern, I'm going to go CD plus 3, because that's what A plus B is. And I'm going to multiply that by A squared. Well, in my problem, A is CD, so C squared D squared. And then minus the first and the last. Well, the first is CD and the last is 3, so I'm going to multiply 3 times CD. and then plus the last one squared. Well, 3 squared is 9. And so that's how you factor this sum of cubes. This example incorporates a couple of our different patterns. First of all, whenever you have an even exponent, that means you're going to square something. So m to the 6th is really m cubed squared. Now, why am I doing that? Because when you have two things that are being squared with a subtraction sign, that's a difference of squares. So this becomes m cubed plus n cubed and m cubed minus n cubed. Now the reason this is interesting is those are two other special patterns, like we learned on the last example. That's a sum of cubes and a difference of cubes. So let's see how we break these up. So I'm going to have m plus n times m squared minus mn plus n squared. That's the first m cubed plus n cubed broken up. And then the second one is the bottom pattern that you see over here. That's going to be m minus n, and then m squared plus mn plus n squared. In our last example, we have some trinomials, so we'll review the diamond, and then we'll also see what happens when we divide. So we'll start with the numerator. The diamond on the top is a -3, and on the bottom is a 2. Two factors of -3 that add to be 2 are 3 and -1. The leading coefficient is a 1, so we use 1x plus 3 and 1x minus 1. There is no reason to deflate, so that's what the numerator is going to be, x plus 3 and x minus 1. Over here we'll do the denominator. Again with the diamond, 12 on top, 7 on the bottom. Two factors of 12 that add to be 7 are 3 and 4. So 1x plus 3 and 1x plus 4. No deflating. That's going to go on the bottom. X plus 3 and x minus 4, x plus 4. Looking to divide these, remember there's such a thing as excluded values, so my x cannot be a -3 or a -4. That's part of my solution. These values are excluded because they create zeros in the denominator. And we can cancel the x plus 3's. That's legal because they're factors, leaving me a simplified expression of x minus 1 over x plus 4.